Hi everyone, second video then on impulse and momentum. This time, after this, we're going to talk about the conservation of momentum principle, but for now, let's just recap where we are. So, we agreed that, well, I told you, and I assume you agree. We agreed that rho equals mv. This was momentum. We agreed that the unit of measure was Newton seconds because a Newton is the same as the amount of force needed to accelerate 1 kilo, 1 meter per second squared. And that was all times seconds, and that would equal the same as mass, and mass is in kg, remember? And velocity was meters per second. So you can see how those two things relate. We also have that impulse is the same as change in momentum, and it's primarily described as ft. And because f equals ma and a is constant in our problems, but in M3 and stuff you'll see that a is not always constant, and we would need integration to work out what impulse is. You need calculus to do you need calculus to do everything basically when your velocity and acceleration and stuff isn't constant. Sorry, your acceleration isn't constant. So we changed f to ma, remember, and then we rearranged using the suvat expression, and we ended up with imp, which is our impulse momentum principle. And then we did a few examples using that. And let's quickly do an example then. You can give this a go, but remember just to check with me before you do that. So we've got a mass of 0.2 kg moving along horizontal surface. We've got a fixed vertical wall, so there's the vertical wall. The ball hits, and it says it's 0.2 kg. The ball hits the vertical wall. The ball rebounds with speed 3.5. So 3.5 is your rebound speed. Remember, it's coming out. Impulse straight away in opposite directions, because there's some spark that occurred literally either side of when the ball comes to the wall and then comes away from the wall. Impulse is that split second, that chain reaction, or that reaction spark just before u and v switch places, in other words. So we've got a u going that way, but we don't know what it is. It's just telling us that the magnitude of the impulse is 2 newtons seconds. So we would need imp, won't we? We must state a positive direction, and we're going to do it at the ball, because the wall itself hasn't moved at all, has it? Because it's a stationary, it's a fixed wall. So doing it at the wall wouldn't help, because the initial and final velocities, haven't changed. There's nothing going on there, but the ball has changed, and that will be able to tell us what's going on. So we've got I equals mv take u. I we know is 2. Mass is 0.2. Final velocity was 3.5, and it is going to the left, so that's okay. And u, so we've got minus, but u is going in the opposite direction, so it's minus minus u. So 2 equals 0.2, 3.5 plus u. So therefore 2 over 0.2 equals 3.5 plus u, and therefore u equals 2 over 0.2 minus 3.5. And we get u as being, so 2 divided by 0.2 minus 3.5, we get 6.5 meters per second. Yeah? Okay, cool. Just put that again. So 6.5 meters per second. Cool. So that's where we were. Now let's go back to where we are. So the conservation momentum principle, what is it? What is the conservation of momentum principle? Well, what it is it's saying that in a fixed space, a free space, free of all external um, all external forces and impacts like heat, friction, all this, all that kind of stuff. So if you imagine two things happening in space on a smooth surface, let's say, so we're talking like snooker balls, let's say, colliding into each other on a completely smooth surface. Conservation of momentum principle says that once two bodies collide in those space, the total amount of momentum is conserved. So it's saying total initial momentum of the system will always equal the total final momentum of system. Okay, so this is where the kind of Newton toys kick in. So you know you've got those balls on a string like this, yeah, those metal balls, and if you move this one over here and then you drop it and smack this one will start coming out, won't it? And then it will come back. And the idea is that in a free space, this thing will just keep moving, keep moving, keep moving, keep moving, keep moving, because energy is conserved, momentum is conserved. Uh, you know, you see what I mean? So let's start using maths to kind of show what this one says. So I've got two balls colliding with each other. So like always, there's going to be an impulse coming out from either side because the two balls will collide and then come apart from each other. Let's say this is mass 1 then. So this is m1 and this is mass 2. So u1 is traveling left for ease. u2 is traveling right, sorry. u1 is traveling right and u2 is traveling right. Now, once they collide, let's say they hit each other and they both continue going in the same direction. So at the moment, everything is relative to the right, yeah? So we've got impulse 1 and impulse 2, but as we know, equal and opposite reactions, I1 is going to be the same as I2. And what we're trying to get is comp, which says that M1U1 plus M2U2 is the same as M2V1. Oops. It's the same as M1V1 plus M2V2. So can you see? Total initial momentum equals total final momentum. That's what we're trying to get to. Where does that come from? Is from this diagram here. So we can say if this is mass 1, this is mass 2. At mass 1, so at 1, we're using imp and we're doing it to the left, aren't we? Because I1 is going left. So I1 is mass 1. V1, because you know I equals mv take u, V1 is not going to the left, is it? It's going to the right. So this is minus V1 minus U1. U1 is also going to the right, not the left. So this is minus U1. So you can see that I1 is M1 minus V1 plus U1. So U1 minus V1. Do you see? If we do the same at 2, imp, this is going to go to the right. So to the right, I2 equals mass 2. Velocity 2 is going to the right, minus, and the initial velocity of M2 is going to the right. So it's just a straight I equals mv take u situation. Since the two magnitudes are equal to each other, since from Newton's law I1 equals I2, we know then that M1 U1 minus V1, that's this bit, must be the same as M2 V2 take U2, that's this bit. And therefore, multiply it out, M1 U1 minus M1 V1 is M2 V2 minus M2 U2. put all the U's on one side, put all the uh, V's on the other side, and you have it. There you go. Proved. That is comp, okay? Just like imp, you need to state a positive direction whenever you use this thing every time. Okay, let's continue. So now we know what comp is. I'm going to ask you to prove that in class, by the way, and imp. We can start to use it. And it will be normally in this context, two kind of snooker balls or two trucks hitting each other or whatever, okay? So let's do this. So particle P of mass 2 kilograms is moving with speed 3 meters per second on a smooth horizontal plane. So it has to be smooth, because otherwise the thing wouldn't work. Remember that it has to be in a closed space, no air resistance, no friction at the moment. Particle Q is 3 at rest. So let's start building this up. So we've got our two particles. I'm going to write P on top, Q on top. Remember, I'm really specific about how you lay this stuff out. Once you start messing with the system, it just doesn't work. Every teacher has a really specific system. So UP, subscript P, you see? Not U1 anymore. Why call it 1 and 2 and stuff when you're going to refer to it as P and Q later anyway? It doesn't make any sense. Make life easy for yourself. And UQ is at rest, so I'm going to put that going to the right as well. They collide, so there's an impulse straight away. And it says particle P collides with particle Q. After the collision, particle Q moves off with speed 7/3 meters per second. So Q is obviously going to go to the right, isn't it? It has to go to the right. Wouldn't make sense if we went to the left. But I don't know the direction that VP goes. I don't know if the balls collide and then VP starts going that way and Q starts going that way, or if Q starts going that way and P follows but at a slower speed. I don't know. So all I can do is guess, and I'm going to guess that it's going to the right. And I don't know though. The maths is going to tell me what it's going to do. So part A, find the speed and direction of P after the collision. So I'm going to have to use comp, aren't I? Because that and that comp formula, which you must remember, is m1u1 plus m2u2 equals m1v1 plus m2v2. You're going to be using this in M2 all the time as well, by the way. So I'm going to take a positive direction to the right. I could do it to the left, but most things are going to the right. Well, all of them are going to the right, so I want to keep stuff simple and keep it all positive, right? So M1 is my P, so that's 2. And then we've got 3, it is going to the right, plus our Q mass is 3. And speed is 0, going to the right, equals our mass is 2. VP at the moment I assume is going to the right, and if I'm wrong, I'll get a negative for a VP, which means it has changed direction. Plus 3, 7/3. 7/3. So, we can find this now, because that's 6 plus 0 equals 2VP plus 7. So therefore, VP must equal 6, take 7 is minus 1, so minus a half meters per second. So therefore, direction is reverse. You don't say direction's left, because I could have drawn P and Q the other way round. You don't know which way it started. So all you can say is speed of VP, so that's what that magnitude sign means. These two things here means absolute value. So speed is half meters per second, and the direction of P has reversed. That's all you can say, okay? Direction reversed, speed is half meters per second. Done. Part B says find the magnitude of the impulse received by P in the collision. Just bear in mind the magnitude is going to be the same at P or the same at Q, because equal and opposite reactions, remember? So I can take it anywhere and it should be the same. Q seems easiest because it's all going to the right. There aren't any different directions to think about. So as soon as it says impulse, I'm thinking imp, state my positive direction, and I'm going at Q. So I equals m v take u, remember, as our formula. So I, the mass is 3, velocity going to the right is going to the right, so that's 7 over 3, minus u is 0, so there we go. So 7 Newton seconds is my impulse. And we're done. A harder example now. So a bullet is fired by a gun, which is 4 kilograms heavier than the bullet. Immediately after the bullet is fired, it's moving with speed 200 meters per second, and the gun recoils in the opposite direction with speed 5 meters per second. Find the mass of the bullet and the gun. Again, you could pause the tape and you could try your own version of this and then meet up, but let's just make sure that we are both on the same track here. So a bullet is fired by a gun which is 4 kilograms heavier than the bullet. So if the mass of the bullet was m, again, you just draw this as 2 particles. If this is m kg, then this is going to be 4 plus m for the gun, isn't it? So g and bullet b. Immediately after the bullet is fired, it's moving with speed 200 meters per second, and the gun recoils in the opposite direction with 5. So before the impulse has occurred, so there is an impulse, isn't there? Because there's a collision between the gun hammer and the bullet, let's say. There is a spark, there is an impulse. Both are going with 0. So UG and UB are both 0. But then once the thing's fired, the bullet speeds off with 200 meters per second in that direction, and then the gun recoils. So it goes the other way in the opposite direction of 5 meters per second. Yeah? So all my arrows are in place now. So find the mass of the bullet and the gun. Well, we're going to have to use comp, aren't we? We have to use comp. I'll do it to the right because most of my arrows are to the right. And let's go. So comp says that M1, so M1U1 plus M2U2 equals M1V1 plus M2V2. So M1, 4 plus M times by 0 plus second mass times by 0. Mass 4 plus M times by not 5, minus 5, because it's all going to the right and this is going to the left. So let your arrows tell you whether your sign should be positive or negative. Mass 200. So therefore, we can rearrange. So this is 0 on the left, and on the right is minus 20 minus 5m, multiplying that out, plus 200m. So therefore, moving your numbers over, you get 195m equals 20. So therefore, the mass is 20 over 195. So 20 divided by 195 is 0.103 kilograms to 3 SF. And remember, the gun is 4 kilos heavier. So this is mass of the gun. So, sorry, this is mass of bullet. And gun mass is 4 plus that. So that gives you 4.1023 SF kilos. And that's finished. Impulse and momentum and conservation of momentum principles. So comp and imp, you're going to use them all the time. And that is it for that series of videos.